So the big difference between energy and nutrients is energy flows. Energy comes from the sun into our planet and then leaves the planet in the form of heat energy. Nutrients cycle. In terms of nutrients, the Earth is a closed system. We don't have aliens coming and dropping off extra carbon. So the carbon that we're using today is the carbon that's been around for the last 4 billion years. I always like to start in the atmosphere when I can. It seems like there's a lot of popular press carbon dioxide in the atmosphere. Again, we're focusing on this molecule carbon. Carbon is an essential building block of all living things. But carbon dioxide is a waste product. Too much of it is a toxin. It kills us. So how can living things get this carbon if it's found in this toxic chemical? Well, we use the process of photosynthesis. This is done by our producers. Producers take carbon dioxide, which is toxic to us. They turn it into carbohydrates, sugar, lipids, fats, waxes, and oil, protein, which is basically all of our structure, our muscles, and our molecules that run reactions, our enzymes, and also our DNA. Producers can pass this carbon on to consumers through the process of consumption. Consumers need carbon for the exact same thing. When these guys die, they're broken down by decomposers. Decomposers need carbon for the exact same thing. All three of these, the producers, the consumers, and the decomposers, can put carbon dioxide back into the atmosphere through the process of respiration. So we have this mini cycle, but we're missing some pieces. If we look at the decomposers, we put them in the right conditions. We put them underground for thousands, if not hundreds of thousands of years. We subject them to the right conditions of heat and pressure. We get our fossil fuels. This is basically our coal, oil, and our natural gas. And this is what we're using right now to run basically all of our technology. Through the process of consumption or combustion, we can access that stored chemical energy, and we put carbon dioxide back into the atmosphere. Now this process right here is what's been getting all of the popular press. We're burning fossil fuels at incredible rates. We're putting an incredible amount of carbon dioxide back into the atmosphere. And this is where global climate change, we're increasing the amount of heat energy we trap next to the globe, which is altering our weather patterns and our climates. Now, the climate is changing. We know this for a fact. The big question is it man-made? Is it because of this? Or is it just natural cycles? And you'll hear this, both sides, want to debate. The popular science peer review articles is saying, hey, human activities, dumping millions and millions and millions of tons of carbon dioxide into the atmosphere is what is responsible for trapping the heat energy and altering our climate. I like to think of it as a juggler. If you have a juggler, he sits there and he's juggling 2 batons or 2 eggs or 2 chainsaws, and you throw him an extra egg or you throw him an extra baton, chances are he's going to be able to catch it and he's going to be able to juggle all 3. You throw him an extra baton after he's got those 3 under control, and he can juggle the 4th baton as well. You throw him an extra one, if he's a really good juggler, he can juggle, all 5 batons. Maybe even juggle 6. But if you have that same juggler who's sitting there juggling 2 batons, and you throw 5 at him, or 3 at him, or 4 at him, chances are he's not going to be able to catch them all. And that's what we're doing. We're taking this carbon that has been trapped in coal and oil and natural gas for millions of years, and we're releasing it into the atmosphere almost simultaneously. Now I say almost simultaneously because it's been about 200 years that we've been burning fossil fuels. And on the geological time scale, where the Earth is 4 billion years old or 4.5 billion years old, it's basically like we're throwing this carbon dioxide at the Earth simultaneously. Will the Earth be able to deal with it? Yeah, the Earth is very resilient. The Earth is going to be around probably for another 4 billion years. But the problem is life is very, very fragile. And the life on the planet might not be able to deal with the change in the climate.